Welcome guys to another video, and this particular video is highly requested by you. We are going to discover flat beams and blocks and how they are made in this particular production company. We are at Promax Manufacturing, a company that is located in Kimbo alongside Thika Road. Watch this video to discover how the flat beams and blocks are made and how they are used to make suspended slabs, because later on in the video we are going to go to a particular site that has implemented this technology. I'm Muema from Property Noma, and let's get into the video. Welcome to the channel. I'm so glad that you invited me to come and talk about this technology. It's very, very popular and highly requested by my community, and they want to learn more about flat beams and blocks. So kindly introduce yourself to us.
Okay. My name is Mureithi. We are based in Kimbo. Our company name is Promax Manufacturing. We deal with mainly with precast beams and blocks for floor slabs. We will show you how we do them.
In the background, we have the blocks. They look quite heavy, and they are...
One is 10 kg.
One is 10 kgs, eh?
Yes, yes.
So what are the dimensions of these blocks?
Now, this is what happens. This is the dimension. The length is 400 millimeter from here to here. And then the depth is 120 millimeter from here to here. And then the width is 200 millimeter from here to here.
Yeah.
Yes.
So I can see they have some...
They have a chamfer. This is where they hold the beams from. Because when you're doing the floor slab, you're not supporting the blocks, meaning we are supporting the beams.
Yeah.
So what happens, these one are supported by our precast beams. We're going to show you how they work. Yeah, so this is the reason that we have this chamfer here.
Okay.
Yes.
And there's also another feature with these blocks. They are hollow.
Yes.
So why are they hollow?
They are hollow because first of all, they reduce the sound. And then the second, they are its resistance. And then the last one is they reduce the weight of the slab. So the weight, the slab is not doesn't have a lot of weight.
Okay.
When you're casting the slab.
So when you say they reduce noise, how does that work?
Normally they reduce the what when you're doing when you are laying them.
Yeah.
You arrange them. Is it diagonally or is it diagonally?
Yeah. Horizontally.
Horizontally, yes.
Yes.
Horizontally. So they go up to the last ladder, up to the beams, your normal laying beam.
Yeah.
So that's the reason they reduce the weight, because of the hollowness. They make the slab to be lighter.
Okay.
Plus you're doing only the 3-inch concrete, so you're not doing the 6 inches concrete.
Ah.
Yes.
I think we'll go to a site and discuss more about that.
Yes, yes.
How do you determine the number of blocks for
now we need
site,
to go to the site and do a quotation for you. We normally visit your site.
Yeah.
We can you can share your architectural plan. You can do an estimate quote with that. Or you can visit your site. You normally have technician on site. We go and take the actual measurement from the site.
Okay.
That's the way to determine. It's a predetermined cost. When you do with an architectural plan, you can give you a predetermined cost of the slab.
Yeah.
Yes.
So all these belong to a client?
Yes, some belongs to the clients.
Yeah.
Others we always make them. Every day we make them, we produce them.
Yeah.
So when you order them, at least an order takes like 7 days, at least mostly 7 days at most.
All right. If you can walk with me. Here we have the flat beams now.
Yeah, these are the flat beams now.
This
is where the hollow blocks, now the chamfer lies on this side and the other side now.
Okay.
Yes. So these prestressed beams, they normally have 6 high tensile wire, the 5 millimeter wire. These are the ones.
Yeah.
There are 6 inside. We're going to show you how we do it. We normally cast them with it's a class 35, because we normally use the cement, the 42.5 cement. We don't normally use the 32.5. Yeah, we normally use
the high strength.
Promax. But bamboo, that's normally what you use.
Yeah.
Because of the QLN and everything.
What are the dimensions of?
Now the width the width is 150 millimeter, and then the depth is 50 millimeter. From here to here is 50 millimeter. This is the depth,
Yeah.
But the width is 150 millimeter. So after every 150 millimeter, you put a block.
Yeah.
The block is 400 millimeter. After every 400 millimeter, you put a beam.
Okay.
That's how it goes. Yeah.
So that's how it works.
That's how it works. And then Customization, you can see these ones, they're different sizes.
Yeah.
Now when you come to the site, we normally customize them according to the size of the rooms. If it's bedroom, we customize them according to the size of the bedroom. If it's sitting room, we do the same, customize the same. If it's kitchen, we do the same. Cantilever, balcony, everything we customize according to the size of the rooms. So normally we have to visit your site to take the actual measurement for that.
So does that mean that there isn't one size that fits for all?
No.
Each beam is customized to
Yes,
fit a particular room.
yes. That we normally do that. That's the reason we go to the site and we normally use the architectural plan to customize those dimensions.
Okay.
Yes. We can do actually up to 6.5 meters. Like those are 6 meters dimension. They are a bit wrong. That I think those are for the lodge. The lodge most of them standard size is 5 meters to 6 meters.
In the market of beam and block technology, you'll find these flat beams and also the T-beams. Is there a difference between
there's a difference because for this one, if you cost it, normally we cost it at 2,000 per square meter. If you compare with the T-beams are a bit heavy.
Yeah.
This one needs support because this one you're going to use props and to support them on the longer side.
Yeah, the timber props.
The timber props. So basically these ones lies on the shorter side of the rooms. If the rooms is 4 meters by 6 meters, this precast beams lies on the 4 meter, the shorter side always. So the longer side is the one that you support with the props and the timber 3-2.
Yeah.
And you normally put a dimension or a spacing of 800 millimeter to 1 meter. So you use less timber.
When you compare to the conventional?
Yeah, you compare to the conventional way. Yes. And then the one for the T-beam, they're a bit heavy. So I always suggest clients to use the flat beam because T-beams, they're made of the same high tensile wire, but they're a bit heavy if you compare to this one. Plus the costing, I think that one goes for 3,000 plus per square meter, but this one is 2,000 plus. So this one actually saves and plus. Even when you're laying them to, maybe you're doing first, second floor, third floor, fourth floor, it's easier for you to lay them. It's very easy because they're not that heavy.
Okay.
Yes.
I get a lot of questions regarding the durability of flat beams and blocks and also the safety.
They're very safe.
How safe are these? Especially, people wonder how do they perform maybe in extreme weather conditions or like earthquakes or windstorms.
They're very safe because at the end of it all, they always actually normally see the floor quality is so bad because we're going to put the link beam. And these normally the precast beams, they're supported by the beams, the link beam, the lintel beam.
Yeah.
So when putting the precast beam, they normally lies in the middle of the lintel beam. And then you put on top of it the BLC and 3-inch concrete. So it's one solid din actually.
It's one solid.
It's one solid din because it is going to be reinforced by BLC A142. Then we have high tensile steel wire. These are 5 millimeter indented, and then there's a lintel beam definitely. So the flat is very stable.
Yeah.
Yes.
I remember having a conversation a while back with someone. He was asking me if these blocks can fall off later on in future.
No, they cannot fall because there's the concrete on top of it. You're doing 3 inches concrete and there's a BLC to support it. So there's no way the beams and the blocks are going to fall at any time.
So once they're installed,
you cast it. It's one thing. It's one solid thing. You're doing 3 inches concrete and you do a concrete on that. It's one thing. It's the same way you do a 6 inches concrete for the in situ, the conventional way.
Yeah.
So this is the same way.
Okay.
So you do this one, you're doing 3 inches. The other one, you're doing 6 inches. So you see, this one, it's half of the conventional way here. So if you're going to use a cement, maybe let's say like cement, how many bags? 100 bags for the conventional way. This one you're going to use 50 bags. Because you're only doing 3 inches concrete, half of that.
Now the floor slab now.
Yes, the floor slab.
This is now the production yard.
Yes.
Kindly take us through the production process of the blocks and the beams in a typical day.
Now, normally what we do, we have this wire. This is the high indented wire.
Yeah.
This is 5 mm wires. We normally put, for every precast beam, we normally put 6 of them.
Okay.
So we pre-stress them from end to end.
Yeah.
Then after pre-stressing them, we normally make sure the tension is high. Like we have a gauge, it's called 570 mph. Then we cast now. That's now the time we normally use now we use the bamboo cement, the 42.5, and then we cast now.
Okay.
And then we leave it for 7 days for curing.
Oh. So
Yes.
this mold,
This is 150 millimeter now. This is the depth.
and then
for
the depth is 50
the
millimeters.
50 millimeter, yes.
That
This is
comes-
wind, then the depth.
Is this some bitumen, or is it oil?
Yeah, it's oil, just a oil.
What is the function of it?
The function of the well is when you cast, the beam is normal, the concrete is not stuck on the floor, so it's easier for us to pull it up. Yes.
Okay, okay.
Yes, so there's the reason for using the well
Yeah.
before we cast. So we use the well and then we cast, we put the chip in, and there's dust, and then there's a kokoto, the half-inch
Yeah.
concrete, the ballast, and then we cast, we do the vibration,
Yeah.
and then the beams are ready to go. Like this one,
So,
this
like
is
on
the
the side
final
there?
product. Yeah, this is now. This one we did them on Saturday. Yes.
So these ones are you're still waiting for them to cure.
Yeah, yeah. Normally
they
they
go to
customize
the
them.
clients.
Yes, we customize them, and they are very. The strength is very okay because of the 42.5, and then the steel wire. Yeah, 5
For
mm.
the
Yes.
575. Eh?
Yes, yes.
Is there a particular case where this beam can span for a house, can span from here to that end?
Basically, not really. It's not recommended in Kenya.
Yeah.
The bedroom standard does not require that because most of the houses we find the lodge and the sitting room spans up to 6 meters, at most 6 to 7 meters.
Yeah.
Because this is 12 meters. So normally what we do when we go to the site, we customize them according to that. But we can customize up to 6.57 meters. But if it's more than 6 meters, we normally advise client.
Yeah.
If the span is more than 6 meters, you normally have to put a silent beam in the mid-row. You can put like, we advise that when you come to the site. You can put like 3D16 for less to balance of the weight.
Yeah.
So that the beams does not warp, the concrete does not warp when you put them.
Yeah.
So when you're doing, even when it's more than 5 meters,
Yeah.
we always advise the client, do a silent beam of, you can put like 3 or 4 D16. It's going to help a lot because it's going to balance off the weight. Plus it onekana huku chini, it's not going to sag.
Yeah.
It's just a silent beam. You're not going to see it at all.
This is where you cut the specific lengths of the beams.
Yes, yes, yes. Yeah, this is how you do it.
Yeah.
After now doing this, there's a lorry there you can see. Then they load, and then they're transported to the site. Actually, what we do for the transport, basically, we arrange for client at affordable rate. We normally have some lorries allowed here, so we normally talk to them and they charge at a reasonable rate.
Okay.
Yes. Yes.
Where do you make the blocks?
The blocks we have another site because of the size of the plot.
Yeah.
We normally make them from Limolu, but we transport them up. We don't charge the client from the Limolu, we charge from here when you're doing that.
Okay.
Yes, yes.
Now let's talk about pricing. How do you, as Promax, price the beams and the blocks?
Normally we place them at per square meter. We can place them at 2,000 per square meter. Per piece, we can place them. The blocks we sell at 85 bob per piece.
Yeah.
And then the beams we sell at 545 per linear meter.
5.5?
545 shillings per linear meter.
Okay.
And then the block we sell at 85 shillings per piece.
So that adds up to 2,000?
2,000, yeah. 2,000 per square meter.
Okay.
Yes, 2,000 per square meter. So when they sell at 2,000 per square meter or per piece, it's more of the same.
So is that affordable when you compare
Yeah. You compare
when
to
you add now the cost
the
of
costing,
the beams and the blocks
yes,
and the 3-inch
the 3-inch concrete. Normally, you save a lot. You save like being reasonably between 40% and 50%. Because now you see now the concrete is going to be 3 inches, so that's half of the conventional way. Second thing, you're not going to use a lot of toppers. There actually not a lot. There's no toppers you're going to use.
Yeah.
So you've reduced the work of for toppers. That will minimize labor and cost. There are not a lot of people on site. So because the only thing you're doing on site for laborers is you're doing the link beam only. That's the only thing you require a person. There are a lot of people on site. Then the other one, it's easier to determine the cost. And then the level of the house, ceilings, it's very level. So you don't need a lot of things to do. You can even decide when after you've done, you're going to see a site. After you've done the beam and block, you don't normally have to plaster. You can do the gypsum directly. You can
Yeah.
leave it like that. So you save a lot on compared to the conventional way.
Okay.
Yes, yes.
And if you compare it now to T-beams and blocks, how much would per square meter?
T-beam, if you compare flat beam and T-beam, it's a lot. You save like, let's say, if you put the T-beams does not use the formwork.
Yeah.
This one uses the formwork.
Yeah.
But you see now the costing, it's allowed. You save. If you use this one, you save a lot, like let me say 20%.
Okay.
Compared to T-beam, 20%, because to T-beam is 20%, to convention it's 40%.
Yeah.
Yeah. So these are normally we use, and then they are lighter than T-beam.
Yeah.
The T-beam are also okay, but you see now the problem, they are a bit heavy. So imagine doing a floor that has 5 floors. It's about heavy. They are a bit heavy. Yeah? Pulling them up, they're a bit heavy.
Okay.
Yes, yes.
Now, what are the advantages of beam and block technology?
First, the advantage is they are lighter. So the house is not as heavy. You've seen some houses falling. So basically, this one reduces the weight of the house. Secondary, the house, it heat resistant, and then it's outproof because of the aura, the blocks that we've shown you.
Yeah.
So when you're on top of it, if something falls or you push something, someone who is downstairs cannot hear you. So that's another second advantage. And then the third one, another different advantage is it's cheaper than the other means of doing the floors. You can even suspend it when you're doing the house. You don't normally have to do the excavation. You don't have to do the excavation. You can suspend them with the flat beams.
Yeah.
You've done
so for like maybe where the soil is black cotton.
Yeah, cotton soil. Yeah. Even the land soil, you can still do it. You don't have to do the excavation, the maram, the article, the chumas. No, you can just suspend with the beam and the block, and then you put a BRC. That slab is very okay.
Yeah. I've seen how fast this technology is in setting up slabs. So in your experience, let's use a typical 3-bedroom house. They want a bungalow, but they want to do a flat roof. So for that, how long would you think it would take?
To lay this one, actually for a 3-bedroom, it's just a day to lay the beams and blocks. If they are laid, you can give us the 7 days for preparation.
Yeah.
Then after 7 days, the 1 day for laying the beams and blocks. Then after laying the beams and blocks, you can cast the other day. So like 7 plus 2 days, let's say a maximum of 9 days.
Yeah.
Yes, preparation of formwork, casting. If the client is ready, basically the cash is ready, everything is ready.
Wow.
Yes, yes.
And for that typical 3-bedroom house, how much do you think?
The typical 3-bedroom house can go up to 170K. You're using the beams and blocks.
170,000.
Yeah. But houses are not the same. So basically that's why I advise the client to normally send the architectural plans.
Yeah.
We work on them and then we set them up, determine at least estimate cost on the same.
And how, because we are talking about those cost savings, for that typical 3-bedroom house, if they were to use the conventional slab, how much do you think that would have cost?
For conventional slab, it's double of that. So it's about 320 or 340. It depends.
Wow. Oh.
Yeah, this goes up to half of it. Because, you're saving, you see those steel bars that you normally use on the mid-rows.
Yeah.
You're not going to use a lot, any steel bar in the middle. The only steel bar you're going to use is for link beam, the length of beam only.
Yeah.
So basically you're saving a lot on that, which is a good thing.
Okay.
Yes.
So Mr. Tony, we are at a site here in Membley where they've used the flat beams and blocks to make the suspended slabs.
Yes, yes.
So if you can use this as an example, you can take us through the installation process.
Now this is the beam and block format.
Yeah.
This is the beam, you can see it. And there is the auto block. Actually, from our first clip, we've shown how to lay the beam and block.
Yeah.
So this is just now how it's done in the site.
Yeah.
So this is the way it's done. The lips normally lies on the shorter side, and then the longer side to support the props. So now they have removed the props. You cannot see the props.
Yeah.
And then this is how you do the plumbing, the plumbing and the conduits. These are conduits for electricity.
You make the
drill
space between the blocks, eh?
Yes, yes. You don't have to tamper with the beams.
Okay.
Yes.
So for this site, this is the shortest span.
Yes, yes.
This technology is also known as beam to beam.
Yeah.
So these beams, the flat beams, are laying from this ring beam to this
that one. Yes. Yes, yes, yes.
For such a span, how long do you estimate the installation process takes?
Just a day.
This is a day's work.
Just a day. The whole house.
Yeah.
Yeah, yeah. Because you're laying the beam and block only.
Yeah.
Yes.
This is a 2-floor house. Right now we are below ground. Eh?
Yes, yes.
Yeah. So you can also move to the first floor. We see
how it's done.
The beams and blocks are laid. So this is now the first floor of this house. Again, they're spanning on the shorter side.
Yeah, they're spanning on the shorter side. That's how it's done. Eh? Then you can see the soffit area is very leveled. You can decide to do plaster and you can decide to do gypsum. You can decide to leave it like that.
Yeah.
Depending on your finances. Eh?
Okay.
Yes.
And the spacing, you said it was between
beam to beam, it's 400 millimeter.
400
because the block is 400 millimeter. There's a groove on the auto block. So between beam to beam, there's 400 millimeter, the block. Beam to beam block. That's why it's called beam and block format.
Yeah.
Beam block format. Yeah.
Okay.
Yeah, yeah. And save a lot actually. Because you can see the props they used, the timber work, it was
minimal,
very minimal.
And now we are standing on the 3 inches of the concrete now.
Yes, yes. No, this is, actually this is what they've done, screeding. This is a 3-inch concrete.
So if you add the thickness of the slab together with the concrete, how
it comes to 6 inches.
It comes to 6 inches.
Yeah, but you're doing the 3 inches on.
So 3 inches is occupied by the beams and the blocks.
So then the other one.
So that's where the saving comes from.
Yeah, the saving comes from. Saving comes from timber work, labor, people on site. You don't need a lot of people on site.
Yeah.
And then concrete.
Okay.
Yeah. Because the spacing you're doing for props and timber work is 800 millimeter, at least 800 millimeter.
Yeah.
Prop to prop or timber to timber, 32 to 32. So it saves on timber and labor work.
Yeah.
Because you don't need any steel bar in the middle. The only steel bar you need is on the length of beam only.
Yeah.
The loud beams.
And the steel that is used is the BRC A142.
A142,
Yeah.
The standard one.
Okay. I hope guys have been able to answer your questions in this video. You've seen how the flat beams and blocks are made at the production yard, and where we are at right now at the site, you've been able to appreciate how they look like once installation is done. I hope to make more videos about this content in future, but as of right now, I really wanted to make a video showing the production process of flat beams and blocks, and I hope I brought all that out in this video. So thanks for watching. I'll see you in the next one.